let's take a look at how we can use our sum and difference formulas for sine and cosines to find exact values of angles that are not just our 30, 60, or 45-degree angles that we've talked about in class. So to do this, I'm going to need to rewrite this expression as the sum of two angles so I can get 75 degrees as my answer. So the trick is to use one of the angles we do know an exact value of. Those were our special angles we've discussed, the 30 degrees, the 45 degrees, and the 60 degrees, and occasionally we'll use 90 degrees or some variation of these in different quadrants. In this case, expressing 75 as the sum or difference of these numbers, I can see is pretty easy to do by saying just 30 degrees plus 45 degrees. 30 plus 45 is of course 75. So the reason this is helpful is then using the formulas we've discussed in class, I can break this apart into, remember we've talked about calling this angle A and that angle B, I can rewrite this as the cosine of A, 30, times the cosine of B, 45, minus the sine of A, which is 30, and times the sine of 45. Okay, and again, that angle or that formula comes from what we've discussed in class. And again, the reason this is helpful is because each of these individual pieces I know the exact values of. I can look these up in the trig chart that we've used in the past. So for example, looking up the cosine of 30, I see that that's the square root of 3 over 2. The cosine of 45 is the square root of 2 over 2. And then similarly, looking up these other values in our trig chart, the sine of 30 is 1/2, and the sine of 45 degrees is square root of 2 over 2. Okay, and so to finish this, it's just a matter of simplifying this expression. Square root of 3 times square root of 2 is just square root of 6 over 4. I can just go ahead and multiply numerators and denominators when I'm multiplying. The second piece is going to be minus the square root of 2 over 4. And finally, since each of these fractions has a common denominator, I can go ahead and just add, or subtract in this case, the numerators. Square root of 6 minus square root of 2, I can't do anything with that other than say square root of 6 minus square root of 2. It does not become square root of 4 over just regular 4. And so there is my exact value of this angle, which we didn't normally have an exact value for. And I can check this using a calculator. Simply enter in degree mode the cosine of 75 degrees, and then enter in this answer down here, and make sure you get the same decimals for each one. Okay, so that's kind of what we're going to be doing with these. I'm going to show you a couple more examples if you want to watch these as well. I suggest for these, just to make them a little bit easier, I always like to work in terms of degrees and not radians. Although you can work in terms of radians, sometimes it's harder to write these as the sum or difference of two fractions. So recall that to change a equation, or an angle in radians into degrees, simply replace pi with 180. So this becomes cosine of 180 divided by 12, which is the same thing as the cosine of 15 degrees. Okay, pi over 12 is 15 degrees. And again, I want to rewrite this in terms of the sum or difference of two of my special angles. Well, this time to get 15, I can do 45, that's a special angle, minus 30 degrees. Okay, and again, using the formula to break this up, I can say that that's the same thing as cosine of A, which is 45, times the cosine of B, which is 30. This time my formula says to do plus the sine of 45 and the sine of 30. Okay, and once again, we'll just go through and look up these values in our trig chart to get an exact answer. Okay, and actually these are the same values we had before, so the only difference is going to be that plus sign in the middle. So this is still square root of 2 over 2. Cosine of 30 is still square root of 3 over 2. Plus another square root of 2 over 2 times 1 over 2. You're going to be, once you do a bunch of these, you're going to be really used to these answers. They always end up being the same or similar answers. I'm going to have the square root of 6, this time plus the square root of 2, over just a regular 4 when I multiply those denominators and add together to get this single fraction. So square root of 6 plus square root of 2 over 4. Many of these answers will look very similar, just some will be positive, some will be negative, but you're going to see lots of square root of 6s, square root of 2s, and square root of 4s. Okay, we'll do one more example, this last one using just a sine, a sum of sines. Same idea as we've done in the other problems though. I would recommend changing into degrees, although you don't have to. I think that's a bit easier to do. So 7 pi over 12 becomes the same thing as the sine of 105 degrees. And again, thinking how I can write that in terms of the sum or difference of special angles, 105 is the same thing as 60 plus 45, of course. Okay, so I'll use my sum of sines formula to break this apart. So take a look at those formulas in your notes. The sum of sines would break apart like this. The sine of angle A times the cosine of angle B, which is 45, and then plus the cosine of angle A, which is 60, and then finish it with the sine of 45. Okay, so those formulas, I don't ask you to memorize those. You'll be able to use those from your notes in class. However, after you do a bunch of these, you'll probably start to memorize the patterns. Okay, and again, I'll look up these ratios in my chart, although probably don't be surprised when you see another very similar looking answer. Square root of 60 is, or sine of 60 is the square root of 3 over 2, times the cosine of 45, which is square root of 2 over 2, plus the cosine of 60, which is a half, times the sine of 45, which is square root of 2 over 2. And again, not surprisingly, once I combine some like terms, I'd have the square root of 6 plus the square root of 2, and all of this would be over 4. Okay, so there's a few examples looking at how to find the sum or difference of sine and cosines.